We are looking at the flue gas analyzer, the oxygen and combustibles analyzer for the Nebraska boiler. The electronics looks like this, okay, and I'll open it up inside. What you will see is not an awful lot. Everything is happening in a CPU that's in here, one in here, and another one in there. These are the power supplies for it. This guy has got two 4 to 20 milliamp signals coming out, one for oxygen, one for combustibles, and then it's got another one that's coming out showing us combustion efficiency. To calibrate the analyzer, there's some solenoids that are activated, and if I look back into that corner over there, those two yellow things are the solenoid valves that are going to admit the zero gas and the span gas. And then if I close this door back up, there's an electronics cable that goes from here up to the sensor array, which is up top. So this is it's an analyzer that is extractive. It's not in situ, but it extracts the sample out and it maintains the temperature high enough that no water will condense and there won't be any damage to the cell itself. So internally, this guy is hot. That flange is running with heaters inside it, and it's being heated up to a controlled temperature. And then inside it, there is another set of heaters, and that raises the carbon monoxide cell or combustible cell up to even higher temperature. If we take a look over here, we want to calibrate this thing. There's a button there which looks like little pages, and right now I'm on the operator page, but I can go down and I can look at data views, and in here, if I select it, I can look at a diagnostics view, and if I look at the diagnostic, there's no entries. This thing has never had any problems. Right now everything is running fine. There's no problems with the analyzer itself. Again, if I go down and I look at a chart view, that's kind of a neat thing. In fact, this guy's got a little trend chart in it, and it will actually show you what the oxygen level is, and it'll show you what the carbon monoxide is. It'll show you what the temperature is, and it'll also show you what the efficiency is running like. Because this guy can actually calculate what the combustion efficiency is. To do that, up on the sensor itself, right here, you will see two cables coming in which are yellow in color. Those are thermocouples, and they're type K thermocouples, which is identified by the yellow wire itself. And they're looking at the temperature in the exhaust gas stack, and we're also looking at the temperature of the inlet air. And so therefore they're able to calculate what the temperature differential is across there and calculate combustion efficiency. You can look those up on tables if you wanted to. This guy will actually calculate it for you, and it puts it onto the boiler display itself for us. I'm going to go back. I'm going to look at data views, and this time I want to look at the signals. Now, he's got 4 pages of this data, and it's actually showing me that the flange block, that is the main block up there, is running at 399 degrees. It should be 400 degrees plus or minus 5 degrees, so we're well within spec. It actually uses a PID control algorithm to control the heaters. There's 4 heaters inside there, and it's actually using a pulse width modulation signal onto those heaters to control the temperature. And right now it's running at 33% of its rate. So basically 33% on time, 66% off time to maintain the temperature. When the boiler gets hotter, that number will come down. Right now the boiler is not particularly hot. If it was really cold, then it would be up quite a bit higher. So it'll heat it, it'll apply whatever it needs to maintain that at 400 degrees. Then we've got another thing that says SCJC, and that's the sensor head cold junction compensation. So there's a thermistor up in where all that electronics is up there. So up in where my laser's pointing right now, there's a thermistor actually in that section right there that is looking at what that cold junction compensation is, so it can give you the accurate temperature. You remember that with a thermocouple, you're looking at the difference between the cold junction and the hot junction, and it's that differential voltage which will tell you what the temperature is. So we needed to know what that was. And right now it's saying it's at 158.7 degrees Fahrenheit. And all that means is that that block up there is being controlled at 400, and then the next terminal block that is down from the block itself is sitting at 158.7. Okay, so it's warm, but it's not that hot. But it is telling you what that temperature is inside that block. The O2 heater. This is a zirconium oxide cell, and so for zirconium oxide you have to have the temperature up around 1700 degrees Fahrenheit for the cell to actually work properly. And so there's a heater in there, and it's telling me that the heater current right now is at 0.97 amps. And normally it should be around 1 amp. If it's running excessively high, you're going to get alarms. If it's running excessively low, you're going to get alarms. But we're sitting right in the ballpark as we stand right now. The voltage on it is 17 volts. The power, okay, is sitting at 16.5 watts. That's nothing more than the current times the voltage. Then I said there was another block in there, a CO block. We actually take and elevate the temperature up again, this time to 750 degrees Fahrenheit. In this case, you are actually injecting a controlled amount of air in there, and the measuring element is a catalytic type element where we're actually passing a current through it. And what it does is that it actually burns off carbon monoxide or hydrogen or whatever the combustible fuel might be, and it changes the temperature. There's a reference cell and a measurement cell. And for that to work properly, you need to be up at an elevated temperature. The temperature that ABB uses is 750 degrees. And it's again telling me the PID control for that block is sitting at 48% right now. So the block is up at the 750 degrees. You'll notice there's a down arrow there, which means, looking at this, there's more pages of information, and it's a lot. So on the next page, and you see now I got a down and an up arrow, which means there's more pages after this, or I could go back to the original page. It's telling me the oxygen right now. It's telling me the EMF coming off of the probe itself. Okay. And then what the last zero and span values were in millivolts for calibrating it, and then what the active zero and span, and they're exactly the same. This is a significant advantage over the analyzers that they previously had, where this guy remembers what your last good values were. And one of the problems you can get into is that if your gas bottles, which if we just look down here, I've got gas bottles down below me. This is my zero gas bottle and my span gas bottle. Well, if one of those bottles goes empty, then what can happen is that you'll be in the middle of a calibration and all of a sudden it's got no gas, and your calibration will be wrecked. If you don't have a replacement bottle, you are in deep trouble, and this was typical of the older analyzers. This new AZ40 remembers the last set of values, and you can actually restore the previous set of values, whereas before they were lost. So somebody was listening when those of us who were using them were complaining. And in the new version, this new machine that came out, there was a back door to be able to get in and get the values back again. Okay, so then I'm going to go down one more page. This is for the oxygen sensor page. And then on my COE, COE means carbon monoxide equivalent. So we calibrated with carbon monoxide. If it was seeing hydrogen coming through, it would actually give us a higher value because it's going to get more heat off of that hydrogen burning, and it would be the equivalent of so many parts per million of carbon monoxide. It would be a much larger number. So that's what the E means. It's carbon monoxide equivalent, basically saying this thing is calibrated for carbon monoxide. And if you've got some other gases, well, it's not going to be exactly the ppm that you think it is. Okay, so then the COE temperature difference, the difference between the active and the reference cell is only at 0.2 degrees Fahrenheit, almost nothing, because there is nothing there. The active temperature is sitting at 69.3 degrees F. The reference temperature is sitting at 669.5 degrees F. And that again is, there's two different cells in there for measuring this combustible. Again, last zero and last span, active zero and active span, and if it's currently calibrated, those are exactly the same. But if I tried to do a calibration and ran out of gas, they would be different numbers, and later on it's going to let me restore the old values. If I go down to the next page, this is showing the raw signals coming in. So how many millivolts is coming from the oxygen probe? The flange block, number of millivolts coming off a thermocouple there. COE block, number of millivolts coming off of that one. So if you want to calculate it yourself using your thermocouple tables, you could. Inlet and outlet thermocouples, those are the two that I showed you up there before, the type K thermocouples, which are measuring the air temperature coming into the boiler and the flue gas going out of the boiler. The transmitter itself is sitting at 92 degrees F, and that's this thing, the electronics. So it's actually giving you an indication. So if there was something wrong there, that thing was running excessively high, it would actually be recorded and be alarmed. And then the cold junction compensation is sitting at 158.7, and the electronics, this package here, cold junction compensation is sitting at 101.7. And I've run out of pages. I've only got an up arrow now, so I've got to go back up. Okay. So that's basically the sensor view itself. Now, I want to calibrate this thing, and so going into calibration, I set it up to go through the configuration page, and I set it up so we would come in under advanced, and we'll go to select, and what it'll let you do is go to calibrate. But we got some things we have to do in advance for the calibration. So if I hit the select, these are the things I can do. I can do a manual calibration. I can do a manual blowback. What they've set this up for is that you can actually take air and purge it backwards to actually clear the unit out, okay, if in fact it's got some blockages inside. Then there's a calibration setup in here, which is going to allow me to tell it what zero gas, span gas, etc. it's got, okay, and how long these things are going to run. How many minutes do you want? And typically it's 5 minutes. The default is 5 minutes, and I left it set at those values. So zero gas content for CO gas, span gas, and same thing with zero gas calibration time. And if I keep going down, there's a there's a recovery time. How long between gases do you want to wait until it's stabilized? And we typically set that for 5 minutes. And I think if I was to select it, you would see, well, I got it, I'm sorry, 1 minute, 60 seconds. It's set for 60 seconds. Back. I think we are at the end of this one. Yes. So I'm going to. So the next one is blowback setup. You can actually have this thing automatically blow back. So what type of blowback do you want? Well, basically a pulse. You want to give it a pulse of air. It's not on all the time. And then the number of pulses. I think I set that for 3. So pulse, and then a pulse, and then another pulse. And later when we do the calibration, you'll actually see it do that. Back, amount of time that it should go on, 2 seconds. So it's only a 2-second pulse, but you could set it for whatever you wanted. If it was a really dirty application, you might want to set that for maybe 20 seconds or something like that. Go back, off time, I think I got that set about the same, 2 seconds, back, and recovery time on there, probably again another 60 seconds worth of recovery time. Go back, scheduled events, you could actually schedule this thing to do calibrations and blowbacks at certain times. It can automatically do it. Personally, I don't like it because of the fact that you're going to be burning up a lot of gas. And I found that these do not really have problems with their calibration. They really are solid. They don't drip very much. Okay, flow rate test. We're going to have to go through and do one of these where we are going to determine how much gas that we need to put in there to make sure that we are overcoming what the extractor is pulling in from the flue. And basically what we'll do is we'll adjust that gas flow up until the millivoltage value stops moving. When it stops moving, that means it's now seeing our gas, not what's coming from the boiler or a mixture thereof. And then manual valve control. We're going to use this right at the beginning. I want to take an as-found test. And so to take the as-found test, we're actually going to manually put in some zero gas, manually put in some span gas, and see what it reads. So that's an as-found calibration. And that way, when we've finished our calibration, we can go back to the operator and we can say, hey, when it was reading 3% O2, it was really 3.5 or 2.5. So your values are going to change a little bit because it was out of calibration. We go back and we're basically exited back out of there. So to do this calibration, we made up a spreadsheet. And out of this spreadsheet, we're going to go through and we're going to fill all this data in. Not everything is on the electronics. Some of it, we're going to take some draft pressures inside the actual machine itself to see whether it's plugged up or not. And then down at the very bottom down here, I've got the as-found values, which we're going to do that early in the game, and then the as-left values when we're actually finished the calibration. So there's quite a bit of information to fill in here down this sheet, which we're going to get from the machine itself. Okay. First thing we want to do is we want to measure what is the air supply pressure. And typically it should be about 30 psi, and right now you can see it's pretty well at 30. As accurate as one of these gauges is going to be. And right now we're aspirating samples from the boiler through. And I've got a draft gauge here, and it's measuring right now that the draft is sitting at minus 0.07 inches of water column draft pressure. So what I'm going to do is I'm going to write that down on my spreadsheet. The air supply was sitting at 30 psi. Duct pressure, this is with the sample pressure right now was at minus 0.7, I think. Yeah, minus 0.7. Now I'm going to turn the aspirating air off. The air valve is sitting over here on the side. Turn that off. Look at my gauge. Pressure's dropping. It's now at 0. Okay, so the pressure gauge has gone to 0. And if I now look at my draft gauge, it is sitting at minus 0.2. Okay, so I'm sitting at minus 0.2, which means the differential pressure is minus 0.5. And if it's more than 8 inches differential, it means you're plugged up inside. Obviously, this guy is really clean right now because he's only looking at a 0.5 inches of water column differential. Okay, the next thing we're going to do is I got to take this gauge off, which is actually connected up at the very top there. There's another connection just to the left of it, and I'm going to take the plug off of that, and I'm going to put a different gauge on here to measure what the actual supply pressure is for, or how much vacuum it's actually pulling. Okay, so right now you can see that there's no vacuum being pulled because I still got the air turned off. Now I'm going to turn the air on. I got my 30 pounds of air, and you can now see that the gauge has increased to 8.4 psi of vacuum. Okay, so, and that's what we're looking for. And it should be running somewhere between 6 and 10. So it's plenty of vacuum coming off that vacuum. Okay, that's good. So from the signals view off of here, we need to know what the O2 heater current is. And that's at 0.97 amps. What's useful about that again is if that current goes up too high or goes down too low, it's indicating that the heater element in there is starting to get in a bad shape. It's time to be finding a new auction cell to replace this one. And they're about $600, $650 each. So you're not going to be holding a lot of them in stock. Okay? So from the gas bottles, I just recorded the oxygen content in the zero gas. There is no CO in it. And on the span gas, we're 9.31% oxygen, 1,810 parts per million CO balanced nitrogen. That's off the data tags for those calibrated or those gas bottles, which that is all certified test gas. Okay, that isn't just gas that came off the shelf, it's actually been analyzed. Now, I also need to know something called a minimum flow sample test. So we got to figure out where there is enough sample gas going in to overcome the gas that's being extracted out by the air aspirator. So to do that, I'm going to go back to configuration and advanced, and I'm going to select it, and I want to go down, I want to go to select, and then what I'm going to do is the flow rate test, bottom of the list there, select. Now, it's smart enough to know that right now the oxygen is greater than 5%, so it wants us to use zero gas. If the boiler was running and the O2 was greater than was less than 5%, say it's down to 3%, which is where we like it to be, then it would tell us to use span gas. It's just got to find a gas that's way away from where you are now. So we're going to apply zero gas to it. So this is the zero gas bottle. I'm going to open this guy up. Back off the regulator. Now I'm going to apply some zero gas on here. Ooh, follow instructions. Next key. So now it's going to tell me to increase the zero flow, and basically until this millivolt number here stops changing. So I'm going to put some gas on, and I've got just under 1 standard cubic foot an hour. Not much happening there. I've just gone up to 3, and you can see the number starting to move now. We've gone to positive 24, still climbing 25, and it looks like it's kind of leveled off. I'll give it a little more gas. So I'm up at 4 standard cubic feet now. Now it's gone to 27, 45. Numbers coming up pretty good. 46. I'm going to give it another little tiny bit. I'm going to go up to 4.5. And oh, sitting at 46. Didn't move. Okay, wow, 47. But compared to what it moved before, it's hardly moving at all. Give it a bit more gas. Up to 5. It's pretty stable in here. I'm going to drop it back down again just to sort of prove this. I'm down to 4, and it's still holding about there. But if I drop it back down further to 3, you can see that it should drop off. There it goes. Okay, and so what our minimum flow sample test is somewhere around 4. And that's about where that 47, 51, something like that is sitting. So the minimum flow sample test is 4. And the pressure on the gauge is sitting at about almost 8. Up at 8 psi. This is just all for reference purposes. Next key says increase the flow another 0.5 cubic foot. So we found the point where the sample gas that we're injecting, or the test gas we're injecting, is just overcoming the sample gas, and now he's telling me to put another 0.5 cubic foot on it I'm going to take it up to 4.5, and that's what we're going to run. Okay, so now we hit the next key. It says adjust the span gas, so it's actually opened the solenoid valve for span gas in here to match the zero gas. So I'm going to open up my drop valve, that valve, and adjust the regulator till I get 4.5. Wow, I'm very close. That's pretty close to 4.5. Okay, next key. It basically just shut off the gases, and remember we put 60 seconds of recovery time in there, so in 1 minute this is going to say it's recovered. So I'm going to hit the next key to come out of the sample flow recovery, and I'm back to the beginning. Now I'm actually going to move backwards because I need to fill a whole bunch more data in on here before we actually go through and do our calibration. So I'm going to back out, and I'll remember how to get back in here. It's pretty obvious. There's the signal views page, and from there I want to know what is the cold junction compensation. So that's 158.4, 158.4. The block temperature is at 399. The CO temperature is 750. We want to know what the calibration, the as found calibration values are. So zero and span for the oxygen. So the next page will give me the oxygen sensor, and the zero is 63.4 millivolts, and the span is sitting at minus 3.8. With the zirconium oxide cell, as the inside the cell, you've got reference air, atmosphere, at 20.9% oxygen. Outside the cell, you've got your boiler flue gas or sample gas that we're putting in here right now. And if there's a difference between them, there's going to be a high millivoltage across it. If they came up to exactly the same, then there would be no millivoltage across it. Now, just like a pH electrode, it's not absolutely perfect. And there's something called an asymmetry error in it. And so that's why I've got the minus 3.8 on there when I've got no differential across it. So now I'm going to go get, I've got to go get the COE values. So that's on the next page. And the COE was sitting at 0 is 0.42. 0.42. And the span is running at, it's a difference, temperature difference. Remember there was two sensors in there and it's looking at the temperature difference across them. And it's actually in degrees Fahrenheit. So it's sitting at 3.23. That's not very much. That's the temperature difference across there for 2,000 parts per million CO. So it's next to nothing. So that's 3.23. And it doesn't have any units beside it. So there's no units on the form. Okay, the next thing we need to do is to do an as-found zero test and span test. So I'm going to bail out of here, back screen, go to configuration, enter, advanced. I want to go into calibrate. Now what I'm going to do is I'm going to do a manual calibration. And I'm going to hit, we should check to make sure that the gas samples are set up properly. So let's go back for a second, select calibration setup. The zero gas, select the zero gas is at 0 ppm, that's right, okay, there was no CO in it. Back, the CO span gas was sitting at 1810, that's what's on my sheet here, 1810, that's what's in that bottle. So back, the O2 zero gas is sitting at 1.01, which is what the bottle says it's got in it. And I'll go back, and the O2 span gas says it's 9.31, which is what was on our gas bottle. So The analyzer knows what we've got in these bottles. So now I'm going to go back out of here, back out of there. I'm going to go up to a manual calibration. I'm going to go to a manual valve control. I want to inject gas and compare it. So I'm going to hit select. It's kind of neat. It's actually going to put the zero gas in, and you're going to see it pop open that little valve and then show us what the O2 reads. So I'm going to hit the up key, and you'll see that my valve just opened, and if you look here, I got test gas going through there at 4.5, and you can see now that the O2 is changing. It's gone down to 2.3, 2.1. It should go down to around 1%, because we say we're injecting 1.01%. Now you're allowed plus or minus 0.1 on here. Right now it's saying we're down to 1.5, which suggests to me that it's out of calibration a little bit. Now it hasn't been calibrated for 6 months, so actually it's longer than that. So not surprising. It's down at 1.4% instead of the 1.01%. So I'm going to go, I could go next key. And what will happen is it'll automatically close the zero valve, because right now it says I got 1.3% O2 and 0 ppm CO. So they're toggling back and forth between the two. I'm going to close the valve, and you can see that the flow sample dropped down on here, and I've got the O2's on its way back up to the top. I'm going to go to the next key, and it's going to tell me about the zero gas. And I'm going to hit the up arrow to open that gas valve, and bang, up she comes, and I've got 4.5 cubic feet, and you can see now that the span gas is on its way down. Now, I forgot to write those values down. The zero was 1.3, and this was at 0, right? And the span gas is now reading 11.1 oxygen, 0.1, and 1559. You don't have to worry about getting these too close. 1567. Let's take that one. 1570. That's close enough. 1570. Now, I'm going to go next to shut that off and go manual recovery. On my sheet, it's telling me that my zero gas, we got 1.3 and 0, and we should have, according to the bottle, been a 1.01 and no CO. And down on this one, the span gas was 11.1 with 157 ppm CO, 1570, I forgot to put the 0 in there, and we should have been at 9.3 and 1810. So they're a little bit out of calibration, which gives us a reason to actually do this calibration. Right now, my manual recovery is only halfway through, so we can shut this off. Okay, we've come to the end of our recovery time, so now I'm going to hit the next key. And I'm going to move up to manual calibration. Now, when I do this, I'm going to go through and select it. You'll actually hear the solenoid popping in there, and I'm going to tell you when that happens. You may not be able to pick it up on this video. But manual blowback, do I want to do it? Yes or no? Okay, and listen. You heard the solenoid click. There's a little bit of bump on the gas there. There's the second one, just click. There's the third one that clicked. Okay, and the blowback is in progress. Now we got a blowback recovery of 60 seconds. Okay, we're just about coming to the end of our recovery, and come on, you. That's funny. Okay, so now I'm up to calibrate. It says, do I want to start the calibration? And I can abort or I can continue. You want to make sure that you've got the gas all set up, because this thing doesn't wait for anybody, and it'll get itself in a real knot if you don't have the gas. So it says I'm looking for 1% zero gas, 9.3% O2 span gas, 0 CO, and 1810 parts per million. So that's what it says it's getting for gas, and it's going to calibrate itself to that. So now I'm going to hit the continue button. As soon as I do, the blowback is going to happen again for a couple of seconds. 1, 2, 3. And then as soon as I get to the end of this, it should now go to calibrating 0. And my 0 gas just came up, and we are now injecting the 0 gas. And this is what the sensor is actually seeing. It's seeing 2.3% O2 and 5 ppm CO. It's sort of telling you what it's seeing is as it's measuring this gas. Now this is going to go on for 5 minutes, so we'll cut this. Okay, in about the last 30 seconds, it actually takes the values that it saw, and you can see it's pretty close. It's down at 0 ppm already, and it's at 0.1. In a few seconds, it's going to take, you'll see this guy drop. Okay, it's shut off the 0 gas. Down here, I manually shut off the span gas. I'm going to turn it back on again, and I'm going to turn the 0 gas off. Now this is just a gym thing. That's me. And that's because I have run into situations in the past where these solenoid valves leaked, and all of a sudden I got a mixture of gas in there and ended up with a mess. So I made darn sure that I got just the gas I want going in there. And I'm going to adjust that flow rate up just a little tiny bit. And that gets me to 4.5. Okay, we're going to wait another 5 minutes. Okay, now what's happened is that it's going through and it's telling us what the actual calibration values were for 0 and span. And so we're on our O2. Let's just see right now. That's CO. This is what is really happening, and this is our span, and this is O2 values. So the O2's 0 value is sitting at, let me get right, 61.8, and his span is minus 5.7. Minus 5.7. So you can see it's changed a bit. It was 63.4, it's now 61.8 on the 0, and it span was minus 3.8, and it's now minus 5.7. On the CO, the 0, the CO is minus 0.12, and the span for the CO is 3.12. And again, they moved a little bit, 0.42 to minus 0.12, and 3.23 up to 3.12. So they have moved. I'm going to exit. Now typically what I do, and we will do this, we'll turn the video off for this, but I go through and repeat it. And I want to see it and see if the values have actually changed from one calibration to the next over just a 5-minute period. Okay, so we cut it off. So the calibration worked out reasonably well. You can see these numbers have moved a little bit from the last calibration we did a few minutes ago, but it's an insignificant amount. So I'm going to exit back out of here. I want to go now to actually put that set up so go down. I think I got to go back down to here. Yes, manual valve control. I'm going to actually inject some span gas first and then the 0 gas. The reason for that is that I've already got span gas in these lines all the way through here, so I might as well do that first. So I'm going to select it, and 0 test gas. I'm going to go next, span test gas valve. That's the one I want. I'm going to open that up. And our span gas should come out somewhere around 9.3% O2 and 1810 ppm CO. You see that the O2 is up at 9.4. Span gas, or the CO, is still climbing. 1750 ppm and climbing. So it looks like that O2 is not going to move, so that's at 9.4. This is our span gas as left, 9.4. And what we should have had was somewhere around 9.3, so we're within plus or minus 0.1 on the O2, that's good. The ppm is sitting at 1816, and we should be within plus or minus 20 ppm of that, and of the set point, and the set value in the gas bottle is at 1810, so we're within spec there. So then what I'm going to do is I'm going to go next. It's doing recovery. I'm going to switch bottles over down below here. Okay, so I'm going to go to next. I'm going to go back in again, select manual valve. This time I'm going to do the zero gas. I've opened my zero gas bottle, sample lines up. So I'm going to inject it. And you can see right now that the O2 was at 20-odd% and it's dropping like a rock. The CO was up quite high and it's coming down. You can see it at 214 now. On the next scan it'll be probably lower, 126. And our O2 at zero gas should be around 1.01 and no CO. So I'm at 1.3 now and 26 ppm, 1.2 and 16 ppm, now 9 ppm, 6 ppm, now I've dropped down to 1.102 and 4 ppm. So we're purging what span gas was left in the sample lines out, and we're almost there. We're within 1 ppm on the CO, and we're sitting at 1.1% on the O2, and you left this thing long enough that the ppm on the CO is probably going to drop to 0, but we're well within spec. We were allowed plus or minus 20 and we're within 1. Okay, so we're good. So now what I'm going to do is I'm going to go next, and next I'm going to go right back past the span test and wait for it to come back out of manual recovery. Our manual valve recovery is complete. I'm going to go next, and I'm basically going to get out of here. We've done the calibration. I'm going to exit that, and I want to now look at my signals view and my O2. According to this, oh, that's CO. Let's go back to O2. The O2 sensor is at 62, which is the last recorded value I had for 0, and span is minus 5.1, which is the last value. And if I go down to the CO page, it was minus 0.12 for its 0 value and 3.12 for its active span value. So that's the calibration complete. I'm going to go back to page 1, which is the operating screen, and there we sit. Okay, and so we are basically done the calibration.